Welcome to Milak Online Tutorial. Now before us is this question in longitude and latitude, and here we are told that an aeroplane flies due west for 3 hours from P, having a latitude of 50° north and longitude of 60° west, to a point Q at an average speed of 600 km/h. Now the plane then flies due south from Q to a point Y 500 km away. Now calculate the longitude of Q and the latitude of Y. Alright, let us start by drawing a pictorial diagram for this question. Okay, now here is the circle. Alright, then now these are the two lines that divide the earth equally. This vertical line west and east, and this horizontal line north and south. Alright, now let's just start solving. Now here we have a latitude of 50° north, so since it's at the north, so we have it this way. Now this is 50° north and longitude 60° west, so this is the west part, so we draw. Alright, so at this point here is P. Okay, alright, and this is 60° west. Now the plane started here and flew due west, so from P it moved due west. Now let us see, this is north, south, west and east. Now let us assume that this is the plane here, so now it moved due west, meaning it moves this way. Alright, so it moves this way. Okay, now that is our point Q, so, and which means it has its own longitude, so this is Q here. Now, and this longitude we don't know, so let us just give it a let's say x degree west also. Alright, and take note that since both of them are west-west, it means their angular difference, we will need to subtract them. Okay, now just put that in mind. Alright, and later the plane flies due south from Q, so from this part it flies due south. Now this is our south. Okay, let us assume that this is the plane here, so it now flies due south, meaning it came down. Okay, so let's say it's come over to this place. Alright, now definitely it will have its own latitude. Okay, so this is Y, right? Okay, now look at this diagram. P and Q lies on the same latitude, while Q and Y lies on the same longitude. Okay, alright, since it's on the same latitude, P and Q, so here we have it. Okay, alright, now let's get to work. Now from this part, first of all, let us calculate the distance between P and Q. You know, basically we know that distance equals speed, that's the product of speed times time. Okay, and the distance, and now for the speed here we have 600. Okay, and times 3, so our distance will now be 1800 kilometer. Fine. Alright, and that distance now is from P to Q. Okay, now as such, now take note that this diagram here is just this. Now this is our P and this is our Q. Okay, now the angular difference here is what we don't know now, because that of P is 60 and the one of Q here we don't know. So let us assume, okay, as I've said it here, let's say this X. Okay, all right. So, and the distance from here to here, if just with what we just calculated now, 1800. All right, now, and this is something as the length of an arc, which is L equals to, okay, let's see, now the angular difference here will now be, since X here is further away from P, it implies that X, the angle for X will be greater than that of P. So let us say this is X minus 60 all over 360. All right, ideally this is meant to be the formula. That will be theta over 360 then times 2 pi r, and which is actually the length of an arc. Now, but this theta is meant to be the angular difference between two locations or two coordinates. Now, and since they are in west and west, then their difference will actually be in form of a subtraction. Now times, now 2 times our pi is giving us 22 all over 7, and take note that r equals to big R cos 30, cos theta, and this angle here is the angle for the latitude. So this will now be 6400 now cos 50 degree. All right, and we are here, we've gotten that L, which is the distance between P and Q, is 1800. So 1800 equals X minus all over 360, okay, then equals times, now here you have 444 all over 7 times 6400, now times cos 50. Now cos 50 here will be, so cos 50 it's 0.6428. all right, now what we need to do now is just to simplify this. Now 360 and 7, we'll move it down to the left hand side, because let us cross multiply. So move 360 and 7 to the left hand side. So here you have 1800 times 360 times 7, then equals X minus 60. Now now the whole of this, let me multiply, then we have now punching our calculator here, we get 180,787.2. all right, now since we are finding this value here, let us divide both sides by 180,787.2. 180,787.2. now we eliminate this, so our final answer here will then be, so here we have it, that X minus 60 will be equals to, now the product of the numerator is given as this, and that of the denominator, I'm sorry, the product of the numerator is given as this and the denominator. So when we divide through, divide by 180,787.2, so we get 25.09. all right, so if the whole of X minus 60 equals 25.09, definitely X will then be 25.09 plus 60, and that should give us plus 60, that would give us 85.09 degree west. All right, so that is that for A. Now let us now do the B part of the question. Now for us to find the latitude of y, now here is the coordinate of y, or the location of y, and here for the q. Now here is the latitude we are looking for. Alright, now take note that this is also a latitude of 50 at this point drawn to the equator, also this drawn to the equator. Now we need to look for the angular difference first. So let's assume that the angular difference here is theta. Okay, now for us to get the latitude of y, now take note that for the latitude, now this is 0, which means as it moves northward there is an increase. So if we assume that this is let's assume this is x, okay, x degree north. So it implies that the angular difference here will be 50 minus 50 minus our angular difference for us to get the coordinate of our y. Alright, which implies that 50 minus the coordinate, the angular difference between q and y will now give us the latitude of y. Okay, so and as that, let us say that our taking a look at this diagram, you see, so equals 50 minus x all over 360 now times 2 pi big radius. And why is really big radius? Because it's the line of latitude now formed at the equator. Originally it's meant to be this formula is meant to be theta all over 360 then times 2 pi r. Okay, and this angle here is the angular difference. Okay, sorry, this is not meant to be here. So first of all we need to find the angular difference first, then after which we now find the value of the latitude of y. So as shown in here, we have an L is given as 500. That'll be theta all over 360 then times 2 times 22 all over 7 times 6,400. Now 360 and 7 come over because we will be cross multiplying, so here you have 500 times 360 times 7 equals theta times 44, 2 times 22, that will be 44 times 6,400. Now dividing both sides by 44 times 6,400, 44 times 6,400. The whole of this will eliminate each other, so theta will then be, now if I have to multiply through, so here we have so the product of the numerator is given as 1260000 and the product of the denominator is given as 281600. Now dividing the 2 here, we have 4.47. So this is the angular difference. Okay, now for us to get this, so here we see that 50 minus theta, minus x equals 4.47. So at the end we have here 50 minus 4.47 equals x. Now 50 minus 4.47. So our x will now be 45.53 degree north. So this is the latitude of y. But if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos. Thank you and God bless you.